Everyone knows that the universe is big. It's the biggest thing there is. But it can be quite difficult to appreciate just how big it is. As big as most people imagine the universe to be, in reality, it is much, much bigger. In order to get a sense of how big it is, it can be useful to start with a familiar object, such as the Earth, and discuss its size in units that are familiar to us. Then the next step involves scaling up from there, introducing new units as we go, but making their definitions and relative sizes quite clear so that we have some point of reference at all times. So let's put this strategy to use and start with the Earth. How big is the Earth? Its diameter is just under 8,000 miles, or a bit less than 13,000 kilometers. To us puny little humans, the planet is very large indeed, but it's still just a speck of dust on a grain of sand on the tip of an iceberg as far as the universe goes. Even the distance to the nearest other object, our moon, is much greater than it appears here, as it is not even remotely to scale. The distance to the moon is about 384,000 kilometers, making it a little more than 30 Earth diameters away. So to make this Earth-Moon system to scale, we would need to put 30 Earths edge to edge, and then the moon. Next, let's zoom out to view the inner solar system, consisting of the Sun and the 4 rocky planets, those being Mercury, Venus, Earth, and Mars. Though we can also see the asteroid belt, let's keep things concrete and take this diameter as being twice the orbital radius of Mars, which brings us to 456 million kilometers. This is more than 1,000 times the distance between the Earth and the Moon. Now let's zoom out to encapsulate the outer solar system as well, which extends to the outermost planet, Neptune, and some dwarf planets with irregular orbits. Again, to keep things concrete, the average distance between Neptune and the Sun is around 4.5 billion kilometers, so doubling that brings us to a diameter of around 9 billion kilometers. This is around 20 times larger than when we capped it at Mars, which goes to show you just how far the outer planets really are. Now, if we are to leave our solar system to view other nearby stars, it will become ridiculous to continue to measure distances using kilometers. We have to switch to the light year. This is the distance that light travels in 1 year, which is equal to about 9.4 trillion kilometers. Looking at our local neighborhood of stars, the closest star to our own, Proxima Centauri, is a little over 4 light-years away, which means it would take several thousand copies of our solar system lined up edge to edge to get there. Interstellar space is quite an empty, lonely place, so don't make the mistake of misinterpreting out-of-scale images like these to think that stars are very close together. Just this section visible here, with only a small handful of the closest stars, must be around 30 to 40 light-years across, acting as our little stellar neighborhood. Next, we can zoom out to see our entire Milky Way galaxy. This has a diameter of a little over 100,000 light-years, which means that most of the stars we can see in the night sky with the naked eye are relegated to a tiny little speck in one of the arms of this galaxy, which is where we live. Next, let's zoom out to view the local group, consisting of around 30 galaxies. The Milky Way is the second largest of these galaxies after the Andromeda Galaxy, which we are on a collision course with. This group has a diameter of around 10 million light-years. Next, we zoom out to view the Laniakea supercluster, home to around 100,000 galaxies. Our galaxy sits in the Virgo supercluster, a smaller section of this larger structure, which has an overall diameter of around 500 million light-years. Then we can zoom out even further to see how the system of adjacent superclusters takes form. We are now looking at millions of galaxies, covering a diameter of at least 3 billion light-years. At this point, we have lost all ability to see individual galaxies, which now just appear like collections of dust. And finally, we can zoom out to view the entire observable universe at once. This structure has a diameter of around 93 billion light-years, which is limited by the age of the universe, since light can only have been traveling to get to us for almost as long as the universe has existed. Therefore, we don't actually know how big the entire universe is. There is data to suggest that the entire universe is approximately 250 times larger than the observable universe, but we really can't be sure, and it certainly could be much larger than that. Now, even though we have traveled a vast distance, we have done so in a series of big jumps between well-defined structures. Let's now take a more continuous journey from the surface of the Earth all the way to the edge of the observable universe and back. This physics-defying odyssey will give us an even better appreciation for the immensity of our universe, so let's buckle up and blast off into space.